Okay, this is our end of course final exam review. Question 1 says, given f of x and g of x, find f of x minus g of x. So to start, you have to substitute by using parentheses. So f of x goes first and g of x goes second. F of x is equal to 3x squared minus 4x plus 6. And then your g of x, which has to go second according to the instructions, would have to go in here. So 3x minus 5. Now both of these parentheses have a 1 in front. And what we have to do with the 1 is we have to multiply it into the parentheses so that we can clear all parentheses. So we'll have 3x squared minus 4x plus 6. The second one, if you notice, the second one has a minus on it. So what that's going to do to the parentheses on the right side is it's going to change every sign. So instead of being a regular positive 3x, now it's going to be a minus 3x. And instead of being a minus 5, it's going to be a plus 5. At this point, all we do now is combine like terms, starting with the highest exponent. Highest exponent is x squared, and that's the only x squared term in the entire problem. So the answer is going to start off with 3x squared. Second highest would be x to the first. So that's your x term. So negative 4 and negative 3 makes negative 7x. And then your final is going to be your constant. Constants are numbers without letters. You put those together, that gives you 11. So your final answer, choice B. Number 2 is a little bit more challenging. This one says, given f of x and g of x, find g of f of x. So what they're going to want us to do now is they're going to want us to actually take this problem, and they're going to want us to plug an entire problem into the other problem. So if you notice, the f function is the one on the farthest to the left. That's going to be the one we're going to substitute into. So what I'm going to do here is I'm going to write down f, but I'm going to go to see what g of x is equal to. G of x is equal to 5x. So I'm going to put a 5x right here. Now my f function is going to be the one that gets all the parentheses. So the f function, which is located right here, it's going to have a few parentheses. So it's going to have, let's see, parentheses squared for the x squared, minus 3 parentheses, and then plus 20. Then what we're going to do is we're going to plug in the 5x into each parentheses. So whatever's in your parentheses, it's got to be in all the parentheses. And then you just have to simplify. So if we simplify, 5x times 5x is 25x squared. Minus 3 times 5x is minus 15x. And then we just drop down to 20. And we can't simplify any further, so the correct answer should be choice C. Number 3 says find the inverse. Remember what inverse means. Inverse means switch x and y. So right now, this question actually does have a y. F of x is the fancy way of writing y. So to simplify this, or to write the inverse of it, we just have to switch the x and switch the y, but keep everything else as is. Then we have to try to solve for the y. So I'm going to add 4 to both sides. Now be careful when you do x plus 4 because they're not like terms, so you just copy it down as x plus 4. And then if we want to get rid of the exponent, we're going to have to take the square root. Whatever you do to one side, you do to the other. And then you have to make sure to remember that when you square root something, there should always be a plus or minus result. So it's going to be plus or minus square root of x plus 4. And then that's our final answer. So the correct answer for number 3 is choice A. Number 4 says, given the graph, identify the graph that is its inverse. So again, inverse means switch x and y. So what we're going to do here to figure out which one is the inverse graph is we're going to find a few points on this graph. So I'll use this one since it crosses through 4 boxes. And I don't know, I'll use this one since that one also crosses through 4 boxes. So what I'm going to do here is I'm going to find the coordinates for these. So the first one that I put down, it looks like it's up 3. So that would be 0, 3. And then the second one that I wrote down would be left 1, which is negative 1, and then up 1, which is positive 1. Now, if I want to try to find the inverse is going to switch x and y. So if this is x and this is y, all I have to do is switch it to 3, 0, and then switch this one to 1, negative 1. Now, I'm not changing any signs. I'm literally just changing the order of x and y. So I'm flip-flopping them, basically. Then what I have to do is I have to go over to the graphs and go find a graph that basically hits those spots. So choice A says 3, 0. There's 3, 0. And then positive 1, negative 1. And I think we're actually done. Let me just show you the other graphs. Positive 3, 0. 1, 2, 3. This doesn't even touch. Positive 3, 0 down here. That doesn't even touch. And then positive 3, 0 over here. That doesn't even touch. So even just by elimination, the correct answer has to be choice A for number 4. Number 5 says identify if the function is even. Remember, there are 3 things you have to kind of know for this question. You have to know even, you have to know odd, and you have to know neither. So let me just do like a mini lesson to remind you what an even function looks like. An even function is going to be anything that you can fold along the y-axis. So if this is my y-axis, not sure why it's changing colors like that. If that's my y-axis and I have a shape that looks like this, I should be able to fold this half over and it lands directly on itself, basically. So that V shape, the y-axis would be the halfway mark of that shape. So that one would be an example of even. If I wanted to do an odd functions have this feature. So a lot of times your odd functions, they're going to be diagonal. So you'll have one part in the first quadrant and one in the third quadrant, or possibly one in the second quadrant and one in the fourth quadrant. Now the big thing about this is it's kind of like a double fold. If I was to take this and fold it along the y-axis, this first quadrant piece right here, I'll put it in bold, this piece right here would fold over and look like this. And then what we would do is we would fold it a second time so that the first fold goes this way and then the second fold goes down. And you can see that when I look at the blue one, if I was to fold the blue one down in this direction, it's going to land directly on top of that red section in that bottom left corner. So because this one is even is the one where you should be able to cut it directly in half at the y-axis. So if I just go like this to all my graphs, there's only going to be one that looks like it's actually going to cut it in half, and that's going to be choice A. What number is this? Number 6, write the equation of the square root function. So you have to know that a square root function has one of these symbols. It says it's reflected vertically. Anytime you have a reflection is going to be a negative. It shifts left 5. Now check this out. If I have my x in here, remember the left and right movement has to go inside with x. The thing about this left 5 though is everyone wants to put negative 5, but remember that because it's in there with your x, it's actually going to lie to you because your x lies. So that's actually going to be a plus 5 in here. And then your vertical shift says down 3. Down 3 would go at the end as a minus 3. So the correct answer for number 6 should be choice C. Number 7 says solve the system algebraically, and then there's a lot of different ways you can do this problem. One way you can do this problem is you can, let's see, I'll start off with just x. I'll notice this x has a 1 on it. So what I would do is I would pair up these two problems and multiply the first one by minus 3. Now the reason why I would do that is to get the minus 3x and the plus 3x to cancel. So we would have to times the entire problem by a minus 3. Then what I would have to do is I would pair up this one and multiply the top one by a minus 2, so that way I can create a minus 2x and a plus 2x. Now that right there, that's actually going to create a problem with only y's and z's, and then you do that process all over again. You try to multiply to make the x, or actually the y or the z cancel, and then you can work backwards once you solve from there. Now I think that's too much work. So another option, these are possible answers. So another thing you can try is you can go into each problem and just substitute in the answers until you find the one that gives you all of these answers over here at the end. Now I have an even faster way to do it. Our calculator can solve these. So we go into our calculator, we're going to go into the equation solver. This is going to be multiple equations at once, so that's called simultaneous, so that's F1. The number of unknowns is X, Y, Z, so there's 3 of them, so I have to hit F2. I'm going to clear this out, because that was from another practice test I did. So I'm going to enter in just the coefficients. So 1, -2, +1, -15, and then I've got 3, and then 4, and then -7, and then +5, +2, -1, -2, -2, and -19. Now you want to do a quick check before you hit enter. You got to make sure that all these numbers are right. So it's 1, -2, 1, and -15, 3, 4, -7, and 5, 2, -1, -2, and -19. One sign mistake, one incorrect number will throw the whole thing off. If you solve it, the top one is the X, the middle is the Y, and the third one is the Z. So our correct answer for number 7 should be choice A. Number 8 says, which of the following is a complete factorization of 2x to the 4th minus 162? So the first thing to notice is when we do these problems, we always want to check to see if there's a GCF. Now 2 and 162, they're even, so I should be able to divide it by 2. And if you don't remember how to do a GCF in the calculator, you go to the regular menu. I got to remember how to do it too. This is good review for me. It's option, F4, F6. Actually, that's not it. It's option, F6, F4, F6, F2. So we would enter in 2, 162. So the GCF is 2, which I've already established. So if I take out the 2, and I can't touch the letters because the second one doesn't have any letters. The only way you can take out a letter as a GCF is they all have to have it. So if I take out the 2, I'll be left with x squared, or not x squared, sorry, it's x to the 4th. So x to the 4th minus, what is that, 81? Now you got to kind of slow your roll a little bit when you do this question because everyone's going to get excited and think that the answer is A. But the fact that we still have exponents means that we could possibly factor some more. So the only one that has these features is the difference of squares. It's got perfect squares inside with a minus sign in between. So I'm going to take the square root. Let me change colors here. I'm going to take the square root of both sides. So that'll leave me with an x and a 9. And the pattern for this is you're going to get the same stuff in both parentheses. Now that was an x to the 4th. So that's going to make this an x squared. And then you'll have one that's a plus and then one that's a minus. And don't forget about that original GCF. Now the fact that these still have exponents means that we could possibly do that again. Now you can't do it on a plus sign, but you can do it on the minus sign because both of these are perfect squares. So this one is going to turn into 2 more parentheses. So this is going to have an x and a 3, another x and a 3 with a plus and a minus. Then we bring down the x squared plus 9. And then we bring down that original GCF. So the final answer for number 8 should be choice D. Number 9 says, which of the following are factors of the expression 2x to the 3rd minus 16? So I'm going to do the same thing kind of like we did on the last question. What I'm going to start off with, though, is the GCF. The GCF here is 2. I don't know why the colors are changing like that. So I'll have 2 parentheses x to the 3rd minus 8. So I'm looking at the choices. I don't see that yet. So the one thing I'm going to notice is this one now has a 3. So that right there tells me it's going to be probably the cubes pattern. So the cubes pattern, if you don't remember how that goes, you're going to have a short parentheses and a long parentheses. This is going to be A and B. This would be AA, AB, and then BB. And then we would use the SOAP acronym to fill in the signs. So I'm going to do the first parentheses by taking the cube root. That's how I get the first parentheses. So that gives me an x. That gives me a 2. So if that x is the a, and I want to do a times a, this would be x times x, which is x squared. A times b would be x times 2, which is 2x. And then b times b would be 4. And then we go put the signs in. S is the same, so it has to be the same as the original. O is the opposite. And then AP is always positive. And then again, don't forget, you have to have that GCF on in the front. So the only one that's going to match that answer, the correct answer for number 9 should be choice D. Number 10 says, which of the following are the solutions to this equation? Now this question, you can do this a few different ways, but no matter how you do it, the problem has to equal 0. So I'm going to take 5x squared minus 28x equals 12, and I'm going to subtract the 12 over. So I'll have 5x squared minus 28x minus 12 equals 0. And what I'm going to do, just so I can save time, this is a complex ABC, and it could get kind of complicated if you do all the steps that I showed you from the beginning of the year. But what I'm going to do here is I'm going to work backwards. I'm a fan of working smarter, not harder. So I'm going to go into my solver. I'll go into my equation solver, and I'll just kind of work backwards. So I'll do the polynomial solver of degree 2. The number in front has a 5. The number in the middle is a minus 28. And then the number at the end is a minus 12. Now this calculator is going to spit out some answers. Now the answers, they go down here at the bottom. So I'm going to have x equals 6. And then the second answer, I don't want decimals, I want fractions. So that's going to give me x equals negative 2/5. Now from that, we can actually work backwards. So it looks like we factored. So this one is just going to be opposite sign, so that would be minus 6. And the second one is going to be opposite sign as well, except the bottom ends up going in the front. So this would be 5x and then 2. So our final answer, though, is the solutions. So if we're looking at the solutions, we need the one that has the negative 2/5 and the 6. So number 10 should be, where am I looking at? Hang on a second. Let me just double check my work real quick just to make sure. Number 10, I believe, should be choice. Hold on a second. I want to make sure I got this right in the calculator. So that gave me the negative, so that gives me a positive. Yeah. So I got x equals negative 2/5 and x equals 6. So it looks like choice A is the answer. Number 11, a student solved the equation by completing the square. Which step did the student make an error? Okay, so I'm going to take the problem and I'm going to just kind of start it off the way I taught it in class in first semester. So I'm going to start off with the problem that they gave me. Then what I want to do is I want to take this equal sign, I want to scoot it over, because I always have to have an empty spot right here. Equals 3. Then what we're going to do is we're going to do that thing I was calling the cycle. I used a picture of the water cycle. So it's a 2-step process. You're going to take this 6 and you're going to divide it by 2, and that's going to give you the number for the parentheses. So that should give you a +3. Then what you're going to do is you're going to pass the 3 through the exponent to fill in this empty number. So 3 squared is +9. But in order to put a +9 here, we're going to have to balance it. We're going to have to put a +9 here. So that way it stays even. So then this right here should be 12. Now it looks like so far, so good. So now what we have to do is we have to try to solve this. So if I'm going to solve this, I have to take the square root to make the exponent go away. And then this right here is going to be x plus 3 equals plus or minus. If I go into my calculator, I can actually type in the square root of 12, but I'm looking at the choices here, and I don't see a plus or minus in any of these problems. So I think step C or step 3 is going to be where the mistake is located. Okay, number 12. Which of the following expressions is not equivalent? So this one is kind of weird because it's asking for things that are not the answer. So what we want to do here is we want to sort of work it out. So 4 plus 3i, and then 3 plus 6i. So we're just going to kind of do it step by step and verify that stuff is there. So I'm going to start off by multiplying 4 times 3 is 12. 4 times 6i is plus 24i. 3i plus 3 is plus 9i. And then 3i and 6i makes positive 18i squared. So I'm looking at the choices. This one is here, but that's not the answer because remember, we want the one that is not equal to it. So choice C is not the answer because it's there. Now what we're going to do maybe is combine like terms. So if I combine these two, I have 12 plus 33i plus 18i squared. And then looking at the choices, it looks like that's choice A. Then what we can do is we can fix this I squared. Remember that an I squared just makes that change signs. So if that changes signs, that means that we can actually combine the 12 and the 18. So if I combine 12 and 18, 12 and 18 is minus 6 plus 33i. Minus 6 plus 33i is correct. So the one that is not in any of the steps that we did is choice D. Number 13 says, again, find all the solutions. So if I find all the solutions here, 5x squared plus 50x, oh, there's no x there, I was just kidding, equals 25. Now this one, we don't actually have to set it equal to 0 because there aren't two x's in here. For example, if this had an x, then we would move the 25 over and then we would just use the solver. But since the x isn't there, there's actually a faster way to solve it. You just kind of treat it like a regular equation, almost as if that x squared wasn't there. So we're going to go like this, and we're going to have 5x squared equals minus 25. Then we divide by 5, and we get x squared equals negative 5. And then finally, you take the square root. Remember that every square root gives you a plus or minus. And then, if you go into your calculator, you might get a math error. But this guy right here needs to be fixed. You can't take the square root of a negative, so we have to turn it into an imaginary number. And then we're left with 5 inside the square root. So plus or minus I radical 5 would be on number 13, choice D. Number 14 says, given the system, graph to determine the solution or solutions. So this one is a calculator question. We can go into the menu. And when I graph, I actually like to use the table instead. You might have to delete stuff that's in there. You might have to change the settings. I have to go to F5. My graph paper goes from negative 10 to 10. So I'm going to start it at negative 10, and I'm going to end it at positive 10. And then I'm going to put my first equation in there. Now, I can tell you guys some things about even using the calculator before we start. Just by looking at the top equation, I can tell you that the starting point for this is going to be at negative 3, negative 2. Your vertex or your starting point is always the h and k value. H is always with x and k is always at the end. H is always lying, so you have to use the opposite number. So I can tell you right now that the graph is going to start at negative 3, and then negative 2. So that's where that shape is going to start. That's our quadratic. Should look like a U shape. If I go and type that into my calculator, so parentheses x plus 3, close the parentheses, squared minus 2. My table is going to give me some ginormous numbers. I'm not going to start putting any numbers in until it fits within the window, which is negative 10 to 10. So I have a dot at negative 6, negative 7. So negative 6, positive 7, sorry. So that would be up here. And then I scroll down. Negative 5 would be at positive 2. That would be right here. Negative 4 would be at negative 1. That would be right here. And then I know that this is a U shape, so eventually it's going to kind of just reflect over that starting point. There's our starting point at -2. So here's where the kind of repeat happens. So it's gonna repeat on the other side. And let me make this kind of invisible almost. This is the halfway mark of this shape. So if I have a dot that's 1 to the left, I should have a dot that's 1 to the right. These shapes are symmetric. So if I'm 2 away from the red line, I should be 2 away from the red line here. And then if I'm 3 away from the red line, I should be 3 away from the red line here. So our U shape looks like this. Second shape, I can go into my table. Let me go back and delete this equation. And let me put in the next one. The next one is just simple x plus 7. So -10, -3, 1, 2, 3. And then -9, -2. And at this point, because it's a line, I'm not even going to look at the calculator anymore because I know the pattern is up 1 over 1. So it's going to go here, here, here. Now, once we get to here, this point right here is important. My colors would work. You'd see that. And then we keep going. Because anytime there's a curve, there's a chance it could touch it twice. So the next spot that we care about is that point. And then after that, we really don't care because all we care about is where they touch. So the answers are going to be the 2 red spots. So one of the solutions is at, what is that, 0, 7. And the second answer is going to be at negative, wait a minute, 1, 2, 3, 4, 5, -5, comma, 2. And these are supposed to be smooth parentheses, but my board is tripping. Okay, number 16. This one is probably one of the lower scoring ones on this test in first semester. But this one right here, you have to make sure that you just kind of know all of your rules. So for example, I want you to notice how that's a 2. So what we want to do here is we want to take every number and turn it into a 2. So I'm going to take 32 and use a base 2 to turn it into a 2 to some exponent to get to 32. Now I know that 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. So this is going to be 2 to the fifth. Now that 32 happens to already have a 1/5 on there, so I'm just going to kind of put that back. And then this is times 2 to the x minus 3. Now on the bottom, this is 2 squared, but it already has x plus 1. So I'll put x plus 1 up here. Our goal was to turn everything into a 2. Now what we want to do is we want to simplify. So I don't want these parentheses here. So if I do 5 times 1/5, that all cancels. So that right there is going to turn into 2 times 2, x minus 3, over 2, what is that, 2x plus 2. Okay, and then what I'm going to do is I don't like seeing 2 different 2's on top. So using the multiplication rule, I have to add those exponents together. So that top is going to end up being x minus 2. And then on the bottom, we'll have 2 to the 2x plus 2. Now, anytime they're on top together, they're going to add. Anytime they're on bottom together, they're going to add. But anytime they're on top of each other, they're going to subtract. So I can combine these 2 2's. I can put x minus 2 first, and then I have to subtract all of the stuff that was at the bottom. So 2x plus 2 goes there. Now that minus sign is super important because it's going to distribute here. So that's going to give me negative 2x. Let me scroll this down just a little bit. So I'll have 2 to the x minus 2 minus 2x minus 2. Because when you multiply a negative in, all it does is change all the signs. And you can put your like terms together. So 1x minus 2x would be negative x on this 2. And then I'll use a different color. Minus 2 and minus 2 makes minus 4. So all of that stuff is equal to that original 2 to the y. So all of this is equal to 2 to the y. And what that means is anytime these bases match, you can cross them out. So y is equal to negative x minus 4. So the answer to number 16 is choice B. Number 17 says, given the expression, perform the division, then if blah, blah, blah equals ax squared bx plus c, blah, 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 what is the value of b? So check this out. This part right here is important. When we do this division, all we need to get to is the second number. So I'm going to use long division on this question. So I'll have 8x to the third minus 2x squared plus 5x minus 1, all divided by 2x plus 1. So what we're going to do off to the side here is I'm going to take the first one on the inside, and I'm going to divide it by the first one on the outside. And that should tell me what goes on top. So this is going to be 4x squared. So my 4x squared has to go above the x squared. And then I'm going to take that and I'm going to distribute it back to this. So if I multiply this, this is going to give me 8x to the third, positive, what is that, 4x squared. Notice I don't like my positive signs. The reason I don't is because I have to change every sign. So I change this sign, let's do it in red, change this sign, and then I'll put everything together. So these cross out. This is negative 6x squared plus 5x minus 1, and then it starts over. So I take the first one on the inside, negative 6x squared, I'll put on top of 2x, so that gives me negative 3x, and actually I can stop. The problem said find the bx term. This is ax squared, this is bx. So I'm done. The answer is negative 3, because they only want the b. Number 18 says use synthetic division to determine which is the root. Now there's a lot of different ways you can do this. You can actually work backwards and just plug it into your calculator. Or you can, what can you do? You can plug it in, you can do synthetic division with each and every one of those, or you just go into your solver. So if I go into my solver, this will probably be the fastest way to do it. Let me just really quickly explain like what I'm talking about. I keep saying stuff and I'm not writing it. If you wanted to, one way you can do this is by using the factor theorem. Factor theorem says if you plug in the value into the x like this, minus 104 parentheses plus 140. I was running out of room, sorry. What you could do is you could take this number and plug it into all of these, 2/3, negative 2/3, negative 2/3, negative 2/3, and you can check, does that actually give me 0? If it doesn't, well then that's not the answer, and then you move on to the next one. And then you would clear these out, you clear that out, clear that out, clear that out, clear that out, and then you would try it with the 7. 7, 7, 7, 7. Now I'm saying that's too long. Another way to do it is by using synthetic division. 6 minus 19 minus 149 minus 104 plus 140. And then we use negative 2/3. We drop it, we times it, and we do all that stuff. But it's just like the last one. You would have to test it possibly up to 4 times. And these aren't in any order like ACT. That's too much work. Fastest way to do this is if it's a factor or if it's a root, it's going to give you a 0, which means it's a solution. So I just go into my polynomial solver. This is x to the 4th, so I hit F3. And I'm going to enter in problem 6. This could have up to 4 answers. So minus 19. Minus 149. Minus 104. And then positive 140. And I believe that's the last term. So if you hit enter, it's gonna do all the calculations and figure out the answers. It says which one is the root. So there's a 7, there's a positive 2/3, there's a -2, and there's a -5/2. So the only one that is the correct answer is 7. Much faster. Okay, number 19, it says which is a factor. Okay, so here's what we're going to try. We're going to do, let's see, x to the third minus 6x squared minus 13x plus 42. Now, because this has 4 terms, we're going to do this one by grouping. So I'm going to put the first 2 in parentheses and the last 2 in parentheses. And I'm going to take out the GCF. So the GCF between the first parentheses would be the lowest exponent. So that's going to leave me with x squared and x minus 6. Then I'm going to do the same thing on the other side, but that minus has to go at the bottom. Whatever sign is right there in that second parentheses, got to go on the bottom. The GCF between 13 and 42 is 13. So this would be minus 13 parentheses x. Hang on a second. Let me make sure I did this right. 13 doesn't go into 42. Let me just double check. Menu, go back over here. 42 divided by 13. Yeah, I was looking at that and I was like, that doesn't seem right. Yeah, that doesn't work. So factoring actually isn't going to work on this. So here's what we're going to do instead. We can do, what is it called? We can do either synthetic division or we can do the factor here. I'll do the factor here. So x to the third minus 6, x squared minus 13, x plus 42. So what we're going to have to do is we're going to have to plug in the solutions to these. So this one would be -2, this one would be -3, this one would be -7, and this one would be -42. Now I'm going to go ahead and do this in the calculator, but I'm going to do it in the table because the table gives me a lot of answers. So I'm going to put in x to the third power, and then minus 6x x squared minus 13x, and then plus 42. Okay, now I don't care what the table says. I don't care where it starts and where it ends. All I'm going to do is plug in the numbers that I put next to the arrows. So I'll type in -2 and hit enter. It needs to give me 0. That's how I know which one is the answer. So I'll type in -3. There it is. That one has to be the answer. Now, just to be safe, I'm going to check the other ones as well. So the other one was -7. It needs to give me 0. And then minus 42. That one needs to give me 0. The other way you could have done that question, the only other way you could probably do that question is by listing the factors of 42, listing the factors of 1. This is the P over Q stuff that we did back in first semester. I'll just go over that really quick, even though I already know the answer. Yeah, the answer was B. So this is P, this is Q. You list all the factors of 42, so 1 and 42, 2 and 21, 42 and 3. I think 42 divided by 3 works. 42 divided by 3. Let me think about this. 42 divided by 3 would probably be 14. 3 and 14. 42 divided by 4. I don't believe that works. 42 divided by 5 doesn't work. 42 divided by 6 does work. So 42 and 6 and 7. So 6 and 7. So that's the list there. And then this is P, and this is Q. Q is the number in front. That's a 1. That's the only list. So these are all the possibilities. And plus or minus, actually. Plus or minus, plus or minus, plus or minus, plus or minus. So this one is even more work because, let me see, there's 1, 2, 3, 4, 5, 6, 7, 8 doubled. There's up to 16 problems we would have had to check. So I'm glad we did it using the calculator. It's much faster. Okay, number 20, it says which of the following are the end behaviors? You just have to look at the ends. The left side is up, so that's positive infinity. The right side is down. Oh, I almost broke my pen. Down is negative infinity. So this is the left side, this is the right side. And if you look at how the problems are written, anytime the negative is, you see how it says as x is approaching negative infinity, this is left and this is right. So the left side has to point up and the right side has to point down. This is left and this is right. Up, down, there's the answer. So problem number 20 should be choice B. Select the solutions. Again, you can work this a couple different ways. You can either plug these in and verify that it gives me 4, but it's going to have to work for both of them. Or you can just solve it. I'll just solve it. Square root x plus 4 minus x equals 4. Then I want to add x. I got to separate the square root from everything else. X plus 4 over here. And then what I'm going to do is I want to get this out, so I'm going to square that, but it's not fair to just do it to one side, so I have to do it to both sides. On the left, this cancels the radical, so I'll have regular x plus 4. This one, we got to write it out 2 times. And then what we're going to do is we're going to FOIL it out, so x squared plus 4x, that's this part. And then plus 4x plus 16, that's this part. Combine like terms. And then get it equal to 0. Subtract that, and I'll subtract 4. 0 equals x squared plus 7x plus 12. And then we can factor this. Now, when we factor, you split up your x, cut it in half, basically. I don't know why it keeps changing colors like that. Then what you do is you try to find 2 factors that multiply to 12 but add to 7. If you're not good at doing that, you can always go into your calculator and go into that solver and let it solve it for you, and then you just flip the signs. Let me change all the settings again. So I'll go into my solver. I'm going into my polynomial solver. Degree 2, forgot the question. 1, 7, and 12. So 1, 7, and 12. Now keep in mind, this thing solves it. I don't want the answers, I want the factors. Answers and factors are opposite. So if I solve this, I have to, if I'm going to change these to the factors, I have to change them to their opposite. So positive 3 and positive 4 would be the answers. Oh, sorry, this says solutions. So since it says solutions, we're going to go with what was in the calculator. That would be minus 3 and minus 4. So the correct answer, minus 3 and minus 4, is choice C. Okay, number 22. Find all the solutions. So 2x to the 1/3 plus 5 equals 13. So what we're going to do here is we're going to try to isolate the 2x to the 1/3. So I'll subtract 5. So that's 8 equals 2x to the 1/3. And then I'll divide by 2. Now I want to get the x by itself. Now here's the catch. Anytime you have an exponent that's a fraction, all you have to do is raise it to its reciprocal. Now 3/1 is just 3, so I'm not going to put 3/1 on the other side. So I'll end up with x equals, be careful, that is not 12. 4 to the 3rd power is 64. Again, if you wanted to try to work backwards, you could always try to plug that in and see if it actually gives you that 13. Last one is write the equation of this graph. So there's no question about it. If you look at every choice, it all has the cube root on every single one. So we don't have to worry about that. Well, what we need to figure out is where's the middle. So it looks like the middle would probably be right here. This is like the starting point or the vertex of this shape. Now, the reason why that's important is because that starting point is 1 to the right and 2 up. This is your h and your k. H has to go inside the x and k has to go at the end. So just by process of elimination, that cannot be the answer. Now, the one where they're going to try to trick you, and we've said this all year long, is h goes inside with x and x lies. So if this is a positive one, you have to pick the answer that has the negative one inside of it. And that's pretty much it for day 1. So hopefully you found that useful.